YWYLL 384 by 288 Thermal AR Glasses Review. Welcome to Techtopia X, where we genuinely test, review, and break down products to help you spend smarter, not harder. The product link is in description. Today we're looking at the YWYLL 384 by 288 1500 Thermal Night Vision AR Glasses in Midnight Blue, a wearable thermal imaging system that combines heat-sensing technology, an AR-style viewing experience, and a built-in POV camera. So, is this product really worth buying? And what do the numbers actually mean in real-world use? The headline specification is a 384 by 288 thermal sensor, which gives you 110,592 individual pixels for detecting differences in infrared radiation. Unlike conventional digital night vision, thermal imaging doesn't depend on visible light. So the basic concept is detecting heat signatures rather than simply amplifying a dark image. YWYLL lists the system with a claimed detection distance of up to 1,500 meters, although actual useful recognition distance depends heavily on the size of the heat source, weather, atmospheric conditions, optics, and scene contrast. The thermal sensor is paired with a 48MP POV camera, giving the glasses a second imaging system designed for recording what you're seeing from a first-person perspective. That makes the device interesting not just as a viewing system, but also as a hands-free camera platform. YWYLL also lists 5x digital zoom, while product information describes dual electronic and optical image stabilization, or EIS and OIS, for the POV camera. In practical terms, stabilization is designed to reduce the visual effect of small movements while recording, which can be particularly useful when the camera is mounted directly on your head. The AR design is another major part of the experience. Instead of holding a conventional thermal monocular in front of your face, the wearable format puts the display and imaging functions into a glasses-style system, leaving your hands available for other tasks. This makes the technology particularly interesting for nighttime observation, outdoor exploration, equipment inspection, and repair work. Why is this such a popular type of technology? The answer is flexibility. A conventional camera records visible light, while a thermal sensor provides information based on temperature differences. Put those systems together, and you get two different layers of information. The thermal image can help identify a warm object against a cooler background, while the POV camera is designed to capture conventional photographic or video information. The YWYLL system is also marketed with additional functionality for fishing and inspection applications, including sonar and an endoscope in some product configurations. That makes this more like a multifunctional wearable imaging platform than a traditional pair of night vision goggles. The listed package weight is around 450 grams, and the frame uses modified nylon with a full rim construction and scratch-resistant lens coating according to available product specifications. The product is also listed with a 1-year warranty. One particularly interesting feature is the hands-free operation. Because the thermal imaging system and camera are worn rather than handheld, the viewing direction naturally follows your head movement. For inspection work, that can make it easier to look around a machine, vehicle, pipe, or other equipment while keeping both hands available. For outdoor observation, the same design creates a first-person recording perspective rather than footage captured from a separate handheld camera. The 48MP camera specification is worth putting into context. Megapixels primarily describes still image resolution, not thermal resolution or necessarily video quality. The thermal sensor remains 384 by 288, while the 48MP figure applies to the visible light POV camera. That's an important distinction because these are two separate imaging systems serving different purposes. The 5x digital zoom also isn't equivalent to a 5x optical zoom. Digital zoom enlarges the image electronically, so the amount of useful detail depends on the original image and processing. Still, having zoom available directly from a wearable camera can make framing and observation more flexible. Another standout number is the 1,500-meter detection claim. Detection means identifying that a heat signature is present, not necessarily being able to clearly recognize fine details at that distance. That's an important distinction with any thermal imaging device. The farther away an object is, the fewer pixels it occupies on the sensor, and atmospheric conditions can also affect the result. So what do all these numbers actually mean? In simple terms, 384 by 288 gives the thermal system a substantial grid of temperature-related image information. 48 MP belongs to the conventional POV camera. 5 times digital zoom gives additional electronic magnification, and the 1,500-meter figure represents the manufacturer's stated thermal detection capability under suitable conditions. Put together, the YWYLL AR glasses are designed around the idea of combining thermal imaging, conventional recording, and wearable display technology in one system. The result is a rather unusual piece of technology. It isn't simply a night vision camera, and it isn't simply smart glasses. It's a combination of thermal imaging, AR-style viewing, hands-free recording, and additional field-oriented functions. For anyone interested in seeing how thermal imaging differs from ordinary low-light cameras, this type of device is especially interesting because it turns invisible infrared information into a visual display that the user can interpret in real time. The technology also has broader applications beyond nighttime observation, including inspection and repair scenarios where temperature differences can sometimes reveal useful information about equipment or components. Overall, the YWYLL 384 by 288 thermal night vision AR glasses bring together several impressive specifications in one wearable platform. A 384 by 288 thermal sensor, claimed 1,500-meter detection range, 48 MP POV camera, 5 times digital zoom, stabilization, and an AR-style hands-free viewing system. The real appeal is the combination. Instead of carrying separate imaging equipment for every task, the concept is to place multiple sensing and recording functions directly into a wearable device. Thanks for watching Techtopia X. If you found this helpful, please like the video, subscribe to the channel, and I'll see you in the next one.